Hi, this is Ahed with Logos Learning, and in this video I will be talking about combustion reactions. So what is a combustion reaction? Well, combustion reactions or chemical reactions are commonly referred to as burning. Now, combustion occurs in the presence of molecular oxygen. So by molecular oxygen I mean O2. And these reactions produce heat, therefore they are exothermic. So the burning of wood here is an exothermic reaction. It is a combustion reaction. Now there are two major types of combustion reactions. The first type is called the combustion of metals or inorganic combustion. Now here we have Fe, and this Fe is 3. So we have Fe3, and this is a metal. Whenever it reacts with oxygen, it produces Fe2O3 or rust. Now another example, magnesium plus oxygen makes magnesium oxide. Now these metals have both combusted in oxygen to form the oxides. Now a second type of combustion, and I think this is the one that you're most familiar with, is the combustion of carbon-containing compounds. So what are carbon-containing compounds? Basically they are compounds that have carbon. So here we have CH4, otherwise called methane. We have C3H8, which is propane, and that's the one that you use in your barbecues. So this is a propane tank. And C8H18, otherwise called octane. And this is the gas that you use in your car. So octane is very precious. Now, when you are combusting carbon-containing compounds, there are two cases. In the first case, we have oxygen in plentiful quantities, so oxygen is sufficient. Whenever oxygen is sufficient, like let's say you're outside in plain air, oxygen in that case is sufficient, we have what we call a complete combustion. Now, complete combustion has two products always. Whenever we're talking about carbon-containing compounds, the products of a complete combustion are carbon dioxide gas and water vapor, H2O gas, because you're producing a lot of heat, so you're not going to have liquid water. It's going to evaporate due to the heat. Now, let's write down the products of these reactions, assuming that there is a sufficient oxygen. Now, CH4, carbon-containing compounds, plus oxygen, which tells you that this is a combustion reaction, will produce, in sufficient oxygen conditions, CO2, gas, and H2O, gas, so water vapor. Now let's balance the reaction. Let's do it in red here. One carbon on this side, one carbon on this side. Great. Here we have 4 oxygens on this side, and here we have 2 oxygens. So let's put a 2 here to balance the hydrogens. I'm saying oxygens, I mean hydrogens. 4 here, 4 here. Now let's count the oxygens. We have 1, 2, 3, 4 on this side, and here we have 2, so we're going to put a 2 here. Now, combustion of propane, C3 plus H8 plus O2 in sufficient oxygen conditions will produce carbon dioxide gas plus water vapor. Let's balance this one. 3 carbons here, and here we have 1 carbon, so let's put a 3 to start with. Now we have 8 hydrogens, and here we have 2 hydrogens, so let's put a 4. So now we have 8. And oxygens, let's see, we have 6 and we have 4, so we have 10 in total. So we're going to put a 5 over here. Now, the combustion of octane, C8H18, in sufficient oxygen conditions, same thing, will produce carbon dioxide gas plus water vapor. Now, well, this is a G, not an S. I have bad writing, as you can see. Now let's balance this one. We have 8 carbons here, and we have 1 here, so let's put an 8 because we have to balance the carbons. Now we have 18 hydrogens over here on this side, and here we have 2. So what should we do here? We're going to put a 9. Let's count the oxygens now. We have 8 times 2, 16 oxygens, and we have 9 more. So what is 16 plus 9? It is 25. How do we get this to be 25? Well, we have a little trick here. If we put 25 over 2, the 2's cancel out when you multiply them, and then we have 25. But this is very ugly to leave as a product of a balanced reaction. So what we're going to do instead is we're going to multiply each coefficient by 2 in order to get rid of this 2 as a divisor of this coefficient. Now, this means that instead of writing 1 here, we're going to write a 2. This one becomes 25 when we multiply by 2. Here we have 16, and here we have 18. Now, 2, 25, 16, and 18 will be the coefficients that you're going to write in front of these reactants. Now, I'm not going to erase and rewrite, but you can do that on your own. So, don't forget, whenever oxygen is plentiful, the two products of a complete combustion of a carbon-containing compounds are carbon dioxide and water vapor. Let's carry on to case number 2, in which the combustion is incomplete due to insufficient oxygen. Now, in the case where there is insufficient oxygen, there are 4 products. We have carbon dioxide gas again, water vapor, so same 2 products as before, but we have 2 added products. Solid carbon and carbon monoxide. Now, carbon monoxide is not very good to have produced by a reaction because carbon monoxide is a poison to your red blood cells. Let's take a look at an example, and then I'll talk a little bit about carbon monoxide. Now, this is octane again. Whenever we don't have enough oxygen, then it'll produce CO2, H2O, carbon solid, and carbon monoxide, and I balanced it ahead of time because it was a bit tricky. Now, what is the problem with carbon monoxide? Well, carbon monoxide is produced whenever the oxygen conditions are not sufficient, such as a closed garage. If you turn a car on in a closed garage, the car will burn the octane in the engine, in the engine, and then it will produce carbon monoxide in the garage, in a closed garage, because there isn't enough oxygen in a closed garage. What is the carbon monoxide going to do? Well, I don't know if you guys know this, but inside your blood, well, the blood is red because you have red blood cells. And inside the red blood cells, we have a protein called hemoglobin. Hemoglobin is responsible for carrying the oxygen, molecular oxygen, to your brain and to all your blood cells in the body, or in your cells in the body, I mean. Now, if you inhale carbon monoxide, then the carbon monoxide is going to bind to the hemoglobin in the oxygen binding site, which means that the hemoglobin inside your blood cells is no longer able to carry the oxygen. So even though you're breathing normally and your blood is running in your body normally, your blood will not be able to carry enough oxygen, and therefore your body and your brain will be deprived of oxygen, and this leads to a very quick and, well, it's not a painful death, but it's a quick death. So you got to be really careful that whenever you turn a car on, the garage is open, otherwise you are running the risk of producing carbon monoxide, which you can't tell that you're producing since it's an odorless gas. So be careful. Okay, so I hope that this video helped, and if you have any questions or if you need help balancing these combustion reactions, write it in the comment section and I'll respond to it as soon as I can. Bye!